We now want to come to the part of STL which deals with containers, in particular the sequence containers. And already in the previous show we gave a demo of a vector and lists and so this should be a fairly easy section for you, because once you understand the syntax of one container, all the other containers are a bit more easy. Okay, so a sequence containers are containers whose elements are arranged in a strictly linear order. So in memory, for example, vectors are always stored in contiguous memory. But we don't want to be worried about the indexing or accessing the elements of the container with hard-coded addresses and so on. So we want to have a nice interface so that it's maintainable. So this is what STL gives you. And the major sequence containers are vector, which is useful for mathematical operations. You can actually create vectors and vector objects and use them in your applications. We got a list as well, which could be quite useful, and dec. And there's no ordering in the in sequence containers, so everything's just sequential. So the a nice bit of buzzword here is the families of abstraction idea. All the sequence containers have the same interface, kinds of interface, same functions. So if you understand one well, for example vector, it's very easy to learn dec and list. A dec is first in first out. It's like a queue at a supermarket with no priority. So all the STL containers are template classes, of course, and they have multiple parameters, some of which are default. So in general, when you're working with vector and list, you just give the underlying data type. In some more advanced cases, you can actually give a sorting criterion, which is a function object, but this particular topic is outside the scope of the course. And something you need to know a little bit about anyway, you might get a job interview, is complexity analysis. So given a container and given a certain operation, what does it take? How much effort does it take in terms of the number of elements in your container to execute? So for example, it might be order n, big O notation. So it's the order of n, in other words the size of the container linearly. It could be log n, it could be n squared, which is exponential. Okay, I've already said if you understand vector one type, you know all the other ones as well. So the general interface of all the sequence containers are the following. We have constructors, of course, so you can have default constructors, you can have constructors of a certain size, you can have constructors of copy constructors and so on. Different insertion functions, so you want to fill your data, your container with data at the end or in the middle or whatever. We have just the concept of with containers, you've got to get it, work it out in your own head basically. If I draw my container here, general container, okay, here we are, a general container. One part is the front and the other part is the back. So you can have push onto the front of your container, so you add more elements. You can pop from the front, you can push from the front, from the back, and pop from the back. So these are front and back insertion. So here's the front insertion sequence. You can always get the first element of a container just by calling the member function front. So in other words, not popping it or pushing it, just getting the values. You just call the member function front, and the precondition, of course, is that the container is not empty. If the container is empty, you can't get the first element. We can push an element onto the front. There's no precondition. We remove an element from the front. Precondition again, it's not empty. And front insertion is in constant time. I'm using big O notation. Here's a really big O. Order 1. In other words, the amount of time is independent of the size of your container. When I say something is of order n, so if I say something like order fn is some arbitrary function of n, it could be polynomial, it could be exponential, logarithmic, whatever. When I say something g of n is big O n, it means that the growth of g as a function of n, I should really put n in here, g of n is less than or equal to some constant times fn as n goes to infinity. So when you let n get bigger, you see the complexity analysis. Of course, order, the different kinds of orders you have would be order n, so it's linearly, log n, which is less than linear, and n log n. And you could also have n squared, which is exponential, so in other words it takes forever. If you want to learn more about complexity analysis, you need to have a look at Wiki and see what it tells you. The front container types are list and deck. So in other words, you can pop something to the you can work on the front with lists and decks. Back insertion sequence, you got a back element, so it gives you the last element, push back, pop back, with the same conditions as before, and back insertion is in constant time. So the back insertion containers are vector, list and deck. So you see now a vector coming into play. The container types, every container type has its element type, the underlying type T. You can get it pointed to the element using an iterator. You can refer to an element by referencing the iterator, and iterators of course to traverse the container. So here's the vector, the most important one. It gives you fast random access to a sequence of dynamically varying lengths. You can extend the length of a vector, as we've seen in the previous demo, and so we have fast insertions at the end, at the back of the sequence. So that's fairly and I think I may be even wrong what I'm saying here. You cannot insert something at the front of a vector. So I'm not sure anymore. I would never do it myself anyway, so that's probably why I don't know it anymore. But the it's probably not possible. If you want to insert at the front or a back, then you're talking about a different kind of problem, really. Where's my pen? Okay. So, oh, sorry. It's becoming a bit of a mess. If you want the deck, you can insert at the front of your deck and at the end, at the back. Let me see. Okay, I've got him. I see him. So here's a deck. You've got elements in your deck. So it's like a queue at a supermarket. You can pop from the deck. You can remove here, consume the information. You can also add to your deck here. So this is, in computer science, it's officially called first in, first out. These are typically maybe interview questions as well. So use a deck. So with a vector you can add here at the end, but probably here not. So it's so the vector has two internal sizes, as we've seen before: the number of elements, which is the size, and the capacity. What are the member functions? You've got constructors, default constructor, copy constructor. You can create a vector with a given size. The begin and end we've seen already. Or begin or end. Or begin is the last element in your vector, and or end is the just one before the first element. So it's in no man's land. You can push back, pop back. It's got a size function, max size and capacity you've seen already. You can index, you can actually access the elements of your vector, and you can reserve memory. We've seen in the demo before. So here's a very simple example. These are things you just need to start practicing with, and we'll see many more examples as we progress. So here's my include vector. I create a vector, a default vector. It's got no elements. I reserved 10 elements, space for 10 elements. I push back 2 elements and I change the first element. I still have a capacity of 10 always, but the size is 2 still, and my first element is 30 and my second element is 20. If I clear my vector, we've seen it in the last demo as well, the size becomes 0, but the capacity is still what it was originally, in this case 10. So a list is a doubly linked list. You need to check what a doubly linked list is. We have backwards and forwards traversals. You can go from the plus plus and minus minus. It's got no random iterators. You cannot spring or jump to a certain position in your list. So the we've got the member functions here as before. They look scaringly similar to the member functions in vector. We've got a number of extra functions here called splice. You can split a list into two different pieces. You can split it up. You can make it unique. What do I mean? It means that duplicate elements are made unique. So in other words, duplicate elements are removed. I can remove all elements with a given value. I can merge two lists. I can sort a list based on some comparator functions. So you can write your own function to compare two values, and I can swap two lists. So here's a very simple example. Here's my main. I create an empty list and I push to the back, push front, push back. I can sort my list. I can reverse the elements in the list, and I can clear my list. Okay, so we've given a very quick summary of containers in STL. You'll see many more later on. I would say at this moment in time, just go off and play around with the vector class and make sure you understand all the member functions in vector. So you make vector of doubles and ints and so on, and list as well possibly. And I would investigate what the concept complexity analysis means, because if you use the wrong data container for the wrong problem, you've got a problem. And of course every container has a front and a back. So here's some quizzes. We talked about it before. A vector of a vector and a vector with the embedded list and a list of lists. The constructors, you have to create objects of these nested classes. Let's say I'm sort of simulating a matrix. So the outside row is your vector, let's say, or a list, and the inside J is my inside data structure. So how do I insert it at a row and a column position? How do I actually manage it? Okay, afterwards, how do I access the elements at a row position and a column position? So how would I write my own matrix classes? So I want to create a matrix class instead of STL, or even the vector. So these are like generic brainstorming questions. The best thing would be to go off and write some software program to create vectors of vectors and populate the elements and see how it works. Okay, so we'll take a break here. This is very short, but it's I think the best way is just to practice, and I've given you enough information to carry on. Use IntelliSense and possibly the book by Josutis on STL, or some other good STL book. So we'll take a break now. Bye.